Hello?
Whoa.
Alright, we're going to math today. By math, I mean do math. By math, I mean not have your earphones out or your cell phone in front of you or,
Watching
you
your
know.
video.
Huh?
Watching your video. I was behind on the last minute, so.
But that's like going to a concert, getting front row seats, and watching it through your cell phone because you're trying to record the thing.
Okay, okay.
You're there at a live show. Be there. And so when you're not actually there at the live show, then you can go back and actually be like, oh, hey, yeah, cell phone footage. So crappy, not good sound and all the other stuff. So I know, tears. I know. See, every time I have a concert, I put on a show. I tell everyone put their cell phones away and just be part of the interactive experience. You know, feel the movement. I know that. Yeah, this is on our calc notes, but not like anyone ever looks at any of these anymore. I still have no views on a lot of these. Yeah. Okay. So, knowing known conditions that guarantee a definite integral exists, and defining the definite integral from a to b, f of x dx, we assume that a is less than b. To remove this restriction, we give the following definitions. If f of a is defined, then from a to a should give me 0. Okay? It should give me 0. And then if a is greater than b, then it would be the same thing as if I had a negative here. And I'm switching it. From a to b is the same as switching it. If you notice, I'm switching my a's and b here, and it now becomes a negative.
What are these a's and b's? Can you explain this, please?
That's the domains. That's the start and finish, the left and right side. Okay, you know when I said, you know, we go through our left side, right side, and I draw a little thing? Yeah.
Just got into integral like
So
fast. We didn't do like anything. You just like
write the line and this number.
Oh, we haven't talked about it yet. We're still talking about,
that's it.
yeah, we're still talking about this. So now, the next one I'm going to do is actually from the table. It's in the notes, or it's in the book. I didn't add it to the thing here, which I was supposed to, but I did not. No, I'm sorry. I'm slacking. So, for this one right here, let's see if I can actually find it. Oh, there it is. Okay. So we're going to start off with the expression from -1 to 4. So we have integration -1 to 4 of my function, which is x cubed minus 2 dx. Now, to do this as sums, we would actually try to make n be my going to infinity. Because we want my delta x here to actually get so small on my graph. So I'm going to, let me see, take the limit as delta x goes to 0. Now, delta x, what did I say delta x is? That's my thickness, right, of every of one of my rectangles. And I'm going to take the sum where n should be going to that's a delta x here. Okay. Let me explain what this is actually saying. So, when we did the Riemann sum, what did we do to each one of those rectangles? We added it all together, right?
Yeah.
Okay. So, my area was the sum, which is my summation symbol, added together of all those where n would be equal to some number partitioning it, right? Breaking up into so many rectangles. N is so many rectangles, right? Okay, so now this, when we're doing this, we're taking n as n is going to infinity. So that means I'm going to have an infinite number of rectangles there. And so as n goes infinity, what happens to my delta x? It goes to 0. It's going really, really small, right? So the thickness of each one of those rectangles is going to be super, super small, right? So as it keeps getting smaller and smaller and smaller, it's going to what? It's going to 0, right? So as my delta x goes to 0, I'm actually finding the summation of all those little rectangles together. So that's what this really means. That I'm going to find it as my delta x goes to 0. The thickness of my rectangles gets small, so minuscule, okay, that it's going to 0, but it's actually not going to be 0, but it's going to 0. It's approaching 0. Okay.
What is I then?
Huh?
So it's kind of like an asymptote. It's never gonna get there.
Yes, it's never. It can't get there, because the thickness, my delta x is going to be a value. So I would not have an area if my thickness of this, I would have a height without a width, and so I can't do anything with that if I have 0 as a thickness. So it would be height times width, which width would be 0, and it cannot be 0, but as it's approaching 0. So this is theoretical, and this is for my partitioning at from -1 to 4. So over my integral, or my antiderivative, from -1 to 4, I'm getting my delta x, my dx, is going to get small. It's going to get really, really small. So now I'm going to show you guys how to do this. So we're going to take the antiderivative of this piece right here.
Wait, so what is I equals 1 at the bottom of this sum?
That's starting right here with my first iteration of this. It's a summation of all the parts, but I can't write it out because my parts are going to go to 0. Okay, so now if you think about it on my warm-up problem, how many parts did I have? 6. It's 6 parts, right?
Yes.
So on that one, n would equal 6, right?
Yes.
So n would equal 6 parts, and I would be my iteration for my first term. So from my first term, I would actually have my first term, in that case, just so happened to be, I don't know, what was it on the graph? It came out to be, what, 2?
Yeah.
On my graph, it came out to be 2. So that was my value I got from that one. So I would be the first term in that sequence. You'll learn a whole lot more about this in Calc 2. Okay? Just realize we're adding together a bunch of chunks, right? That's what this symbol is, summation. So I'm adding together, it's the sum of all my pieces. And all my pieces have a thickness that's eventually going to 0. Okay, so let's do the antiderivative of my function there. That's going to be x to the
X to the 4.
over minus 2x. Now, it's not going to be a plus c, and you'll see why. Because I'm going to add it here, but I'm going to show you why. And my bounds are from -1 to 4. My bounds are from -1 to 4. So it's always going to be my top minus the bottom. So it's going to be, I'm plugging in the top and I'm minusing the bottom. 4 to the 4th, what's 16 times 16? 256. So 256 over 4.
Wait,
16 4. 64. This should be 64, right?
yeah.
Minus
Are you plugging in?
8. Yes, I am. I'm plugging in the 4. Plus c, right? Okay. Minus the bottom. Minus the bottom. So it's going to be 1/4. And that's going to give me plus 2 plus c. Yeah. So when I'm subtracting my lower bound, okay, because I have to distribute the negative, I distribute the negative. So now it's going to be right here. So that's going to give me, what's it, 56 plus c minus 1/4 minus 2 and minus c, right? So the plus c and minus c go away. Those things go away. So now that's why I said when I'm having bounds for the definite integral here, that the c is not going to matter because I'm going to add it to one side, I'm going to subtract it to the other. So together, that's going to give me
53 and 3/4.
53 3/4. 53 3/4. Oh, okay.
So it's going to be our answer
Yep.
So, what was the question?
to find the area under the graph.
Yeah. Of the definite integral. So I showed you and
That's
I.
how we did the integrals.
Yeah, that's how you do an integral there.
That's not that hard.
Yeah, that's what I've been saying.
Just
But I gave you guys reasoning because we've been doing Riemann sum and we're doing the sum of the rectangles, but now as the rectangles of thickness, my delta x is going to 0. So it gets more and more as my n goes to infinity because I have that many parts, right? I'm dividing it up into infinite number of rectangles. As I divide it into infinite number of rectangles, my thickness of each rectangle keeps getting smaller, right? That's what I've been trying to say. That's all I'm trying to get at.
still, but like, what does that I mean?
The
I mean, like,
first
it's like-
iteration, that's the
it's
first
like-
the
it's like
first
the
term of this.
It's like the first derivative, second, but
No,
but
it's
I
not.
mean-
No, it's not.
I mean, no.
It's
We're just gonna change delta x so it goes.
we're not. No.
So what is I for then?
Okay. I apologize for showing this to you.
No,
Okay, it's the first
no.
iteration on the summation of these parts. So it's the first term of the sequence of things that I have here. But this is just a format of what we're doing so I could explain that my delta x is going to 0 as n goes to infinity. Don't worry about that. That's the first term. Okay, thank you. All right, so now next one. Let's see. There we go. So let's try this next one. So it's going to be from 1 to 2 of 3dx. Okay, so we're going to take an antiderivative, which is going to give me 3x. 3x from 1 to 2.
Wait, let's see.
All right. So my top bound is going to be 3 times 2, which is 6, right? Minus my lower bound, which is going to be 3 times 1, right? So 6 minus 3, which gives me 3.
Oh, I like this.
You,
That's cute.
that, you like this?
Yeah, that's cute.
How is that cute?
Why did I feel like that was strangely simple?
0 to 3, 3x minus 8. All right. While you guys are staring at me awkwardly, I want you guys to do this one.
Okay.
I'll make an attempt.
Negative 10.5.
I don't know.
You know.
I don't know. Haven't done it yet.
Yeah, he's trying to take that point. But
Can area be? That's a good question. Mr. Pacho. That was such a nice question.
I bet he does.
Because we've got a negative area, but area cannot be negative.
I'm still trying to figure out how you got a negative.
Yeah, I got a negative 2.
You got a negative 2?
Because the second one is 0.
yeah, he's saying
And there's like,
you know, 147 over 40.
Let me see. That's gonna be
27 over 2. Minus 24. Minus. It doesn't matter.
what's that gonna be? Negative
13.5.
48 over 2, negative 48 over 2, which is going to give me 121, negative 21 over 2. So, what does that mean?
The-
Negative area.
The graph is going under
Oh,
the.
Yes, it is, under the axis. That's all it means.
But so, if they will ask us the value of the area of your graph, should we put negative or just?
Yeah, it's negative. Because you have to calculate and you're going to have a top minus a bottom and together. So I'm going to show you guys calculator now. 3x minus 8. Watch. Document. Let me go graph here. 3x minus 8. Enter. Ooh, look. And from 0 to 3 is right here, isn't it? Menu. Analyze graph. What do I want? Integral. And lower bound. Listen, you could either move this or just type in the number. 0. Enter. And then what's my upper bound? 3. Enter. There it is. So it's a lot below and a little bit above. Is that pretty easy? Now, let's go back to Scratchpad. Now, watch this. So, menu, calculus, numerical integral from 0 to 3, and what was it, 3x minus 8? and dx. There you go. The calculator will only do the numerical ones. It won't do it if it doesn't have bounds, a definite integral.
It's very easy.
All right, so now I got a new problem for you.
You gotta do a problem for us.
All right, so this problem is going to be from 1/2 to 4 ln x.
So when you say you read it from the bottom,
Huh?
like it's like 4.5, so you read from the bottom 1/2 to the fourth. not
Yes,
the
because
fourth.
you read it, yeah, from reading it from left to right. And so, and if your a value is less than your b value, then you would switch it. It'd become a negative integral. That's what I showed on the notes a couple minutes ago.
What does AntiDerivative do?
Yeah, it's a question.
Okay, let's see what the calculator says.
Oh, wait.
There, listen. There's you need calculus 2 to be able to find that. Otherwise, it's just an identity.
No, it's just we can do it by graphing. Yeah, but it's not.
Menu, calculus. So, 0.5 to what? What was the top?
4.
4, and it's ln x, ln x
Yeah.
dx.
Oh, so yeah.
What is the?
Wait, so how do you do it if you know calculus?
There is, it's an identity. You treat it like an identity.
There's like a formula.
Yeah, there's an identity. It's in those flashcards I gave you. Yeah.
Um,
All right, so
wish I had.
there we go. On this one right here, don't forget, like, share, and subscribe.
Notification.
Yeah.
So